Hello my dear friends, welcome to a new video. Today we're going to solve the majority element problem on LeetCode. As an input we will have an array of integers, and as an output we need to return the majority element. What do we mean by majority element? The majority element is the element that appears more than n divided by 2 times on the array, with n the length of the array. Okay, so in this case the length of the array is 3. 3 divided by 2 is 1. And the time that the count of 3 in this array is 2. 2 is superior than 1. That means that 3 is the majority element. For the second example, we have 2, 2, 1, 1, 1, 2, 2. So we have 3, 6, 7. We have 7 elements here. 7 divided by 2 is 3. And 2 has 4, appears 4 times in the array. So 4 is superior than 3. That means that 2 is in fact the majority element. Okay, now how are we going to solve this problem? As always, and as I said in my previous videos, and as I mentioned so many times, the first approach is better to have, a brute force approach so that you can get an idea about the problem. So here I'm gonna just write down an example. Okay, 1, 1, 2, 2, 2. Okay, and as you can see here, the majority element is 2. The length of this array is 5. This is the majority element. So the brute force, how are we going to do the brute force to solve this problem? So first of all, we're gonna have an iterator E, okay, and another one called G. Okay, so first of all, we've selected the first number, okay, 1. Now our goal with G is to count the number of times where 1 appears in this array. Okay, so G is now here, so we have the count equals to 1. Now G will go to here. Okay, we have another 1, so the count will be incremented to 2. And then we're going to go there, the count won't be incremented, and go here and go here. So we have 2. And after we finish, what we're going to do is compare the count with n divided by 2. In our case, it's 5 divided by 2 is 2. And the count needs to be superior than n divided by 2 in order to be, so that that element, okay, can be a majority element. So in our case, that's not respected. So 1 is not a majority element. Now we're going to move on to the next element with I. Okay, and we're going to do the same. G would be here, and we're going to count again 1. And after that, we're going to arrive to 2. We're going to count 2, and we're going to find that the count is equal to 3. That is superior than 2. That means that 2 is in fact the majority element. And as you have noticed, we calculated the count of this, and we're going to calculate the count of this. So this is not an efficient solution, but that's okay. It's a brute force solution. We don't care about that at first. So the time complexity for this algorithm would be O of n squared, because we will have 2 nested loops, and the space complexity is only O of 1. Now let's try to code that solution. So we will need a count initialized to 0, okay? Not really initialized, I'm not going to initialize it here. And we're going to need an I equal to 0, E inferior to E nums length, E++, and here I'm going to put my count to 0. And then I'm going to have my single loop, G equal to 0, G inferior to nums dot length, G++. And if my nums g is equal to nums I, what I'm going to do, I'm going to increment the count. And after I finish, I need to compare the count with n divided by 2. So nums dot length divided by 2. And if the count is strictly superior than the nums dot length divided by 2, that means that the nums I is actually the majority element, so we can return it. And if we don't find any majority element, we just return -1, just in case. Run the code. Hopefully we didn't make any mistake. It works. I'm gonna submit it. Probably we'll have a time limit error. Yes, time limit exceeded because it's O n square. Can we do better? And the answer is yes. For example, we could choose a hash map. With a hash map, we'd have keys and values. Okay. In the key, I'm going to put the numbers, and in the value column, I'm going to put the count of that key. Okay, so we have now our hash map, our data structure ready to be used. I'm going to clean a bit my array. Okay. Okay. Oops. Didn't mean to do that. Okay, so now I'm going to loop through my array. I have my I here. Okay, 1. I'm going to add it to the hash map. And we have only 1 count. I'm going to increment again my I. I is into the next element. Oh, we have 1 already exists, so I'm going to increment its value to 2. Oh, 2. And then we're going to here. 2 doesn't exist in the hash map, so I'm going to create it and set its value to 1. Increment again 2. Okay, it already exists. We're going to increment to 2. Again 2. We're going to increment it to 3. And then what we need to do is we could either, okay, so we have 2 options here. After we finish, we could loop through again all the values, all the keys, and check their values. And then if we see that value is greater than n divided by 2, strictly greater than n divided by 2, we return that key. Or the moment we add a 1, we can check if the value, the new value, will be superior than n divided by 2. And I think it's better this way. Okay. So the time complexity for this algorithm would be O of n, because now we will have only 1 loop here, okay? But the space complexity this time would be O of n. Cool, now let's try to code that. We will need a hash map of integers. I'm gonna call it count nums count. Seems cooler. Nums new hash map. Then I'm going to loop through my nums. E inferior nums dot length e plus plus. Okay. Then I'm going to now add to my nums count, add or put maybe. Put. Okay. What I'm going to put my nums I, and I need to get the value of that nums I, the count. I think there is a function called get or default. So if the key doesn't exist, so that means that we haven't added it yet. So we're going to initialize it to 0, to 1. I mean to 1. Okay. So let's go through again this. I'm going to put the key nums I, and if the nums I doesn't exist in the hash map already, I'm going to return the value 1 with this, okay? And no, I need to, no, I made this mistake. I'm going to return 0 and plus 1 here. Now it's correct. Okay, so nums count will get our defaults. Nums I, it's going to return the current count of nums I if it already exists in the nums count, or 0 if it doesn't exist. And we're going to add 1 to it. Okay, that seems fair. We could check now if nums count dot get nums I is superior than nums dot length divided by 2. If you are in this case, we just return nums I. And if you don't find anything, return -1. Run the code. Works. Submit the code. Works. Perfect. 22 milliseconds. Now the question is, can we do better? Can we find a solution with just O of 1 space complexity and O of n time complexity? The answer again is yes. Okay, let's see. How are we going to solve it? I'm going to create a variable called votes. And imagine with me, this array represents votes of some citizens. And the numbers that are here in this array are the identifier of the candidates that are in the in the election, for example. So I'm going to just add candidates variable. I don't have enough place here. I'm just going to remove it. I'm going to put it down here. Candidates. So as I said, we are on an election, and this array is the votes of the different citizens, and 1, 1, 2, 2, and 2 represents the ID of the people, the candidates that are in this election. Okay. So at first, we're gonna consider that our first candidate would be the winner, and initialize the votes to 1. And then we're going to go here. Our I would go here, and we'll consider that, and we see that 1 is equal to the candidate, so I'm going to increase its votes to 2. Now we see our I is here. 2 is different from the candidate, so the votes will be decreased by 1. I'm going to put 1 here. Again, I'm going to go here. Two is different from the candidate, so we're gonna put 0 now. But still, we're gonna keep the candidate 1. Okay? And then at the last checkpoint, we're gonna see that now 2 is still different from 1. So now the votes will be negative if we try to remove it. So at this situation, what we do is we're going to reset our vote to 1 and the candidate to 2. Okay. So simply we will have two variables: votes variable that keeps track of the number of votes at a specific moment, and the second variable will hold the candidate as a majority element. And then we loop through my array, and if the current number is equal to the candidate, we increase the votes. If it's not the case, we decrease it. It's like, you have a vote, but another candidate has a vote. It's like it cancels each other votes. Okay, and we're gonna do that. And if the votes are at 0 at some point, and still the next vote is the next candidate selected is different from the current candidate, at that point we change the candidate to the next one. Okay, it's really simple. Now let's write the code to understand better the solution. So as I said, we're gonna have a variable called votes, going to be initialized to 1, and candidate will be initialized to name nums 0. And this time, instead of starting from e equals to 0, we're going to start from e equals to 1. E different nums length e plus plus. And obviously at the end we return the candidate, the winner. Okay, now first thing we check if candidate is equal to the nums dot I. What we do to the votes, we increment the votes, else we decrease the votes. If at some points the votes are negative, we're going to set the votes to 1, and we will have a new candidate called nums I. We can actually can we simplify? Can we simplify this? Can we simplify? Yes. Can we simplify? Yes, we can simplify. Okay. Yes, we can simplify this. So votes plus equal candidates. Candidate equals to nums I. If they're equals to nums I, we're gonna add 1. If it's further definite, we're gonna have a negative 1. Just to simplify a bit. Okay, nothing fancy. Okay, looks good to me. We're gonna run the code. Hopefully it works. Yes, it works. Submit the code. It works now. 1 milliseconds. It's quite fast. And for this time, we didn't need an array or a hash table or hash map. I don't know. So the time complexity is still O of n. We had 1 loop, and the space complexity is O of 1. So this is it. Thank you for watching. See you in the next video. Bye.